So today we're going to finish, thank you, chapter 1. We don't have a test over just chapter 1. It'll be the conclusion of chapter 1, which was 1.3 to 1.7, and then chapter 2 when we get to the end of chapter 2. So we've still got a little bit till we get to there. But you do have a quiz on Thursday that will cover the parts in chapter 1 that we haven't finished. Or that we have finished but haven't been quizzed over, I should say. So your last quiz was over 1.3 and 1.4, right? So this quiz will be over 1.5, 1.6, and 1.7. So 1.7 we will finish today. So what we're going to be looking at in this section is linear and absolute value inequalities. So we've been focusing in this chapter 1, on equations, solving all these different types of equations. And we're going to use a lot of those ideas in this section, but we're going to extend them to what happens with inequalities. So a few different notations that you have probably seen most of these before, but if you haven't, then we're going to run through them. And if you have, then they're a reminder. There's 3 different types of things we're going to be interchanging between in this section. So that's set notation, interval notation, and then the graph that represents either one. So set notation looks like an inequality with the inequality less than or greater than kind of symbols. That's set notation that we're going to be using. So if x is greater than or equal to a, and we were wanting to look at a graph for that, then what we would do is we would put the a on the graph, and we would need to shade it in the direction that's greater than a, which would be to the right of a. So I'll just use the red color since the one on the bottom is done that way and draw it out like that. And it continues indefinitely, like it forever, because all those values are greater than a. And if I'm being more clean and more precise, I should have arrows on the end of my number line as well. So that's what a graph would look like. I really like interval notation because it mimics the graphs so very nicely. There's one thing missing on my graph. If you'll notice down here on the graph on the bottom, we have parentheses and brackets present. I don't need one on the right-hand side because I've got that arrow drawing. But what happens is that at the a value, I will use a bracket when I have the equal sign underneath, and I'll use a parenthesis when I don't. So ours on the first part has a bracket at a, and the bracket always opens toward the shading, right? So it would not be that we would have it like that because there's no shading on the left-hand side. It would definitely be opening in this direction. So if we take that graph and we read it from left to right, our interval notation naturally comes about. The first time I have location where I've shaded on my graph starts at the value of a, and at the value of a I have a bracket. And then because it continues indefinitely, I say that it continues to infinity, right? Infinity would be this indefinite idea. And then anytime I have infinity, just like you're going to see this negative infinity down here on the second line, I'm going to use a parenthesis. So brackets really mean that I'm able to equal a value. Infinity is not a number, so I can't equal it. That's why it gets a parenthesis all the time. All right, so let's actually take the interval notation on the second line and do the graph for it, and then we'll go back and do the set notation for it. So if I have my number line, and I have my value a, this actually tells us that we shade from the left-hand side negative infinity until I get to a and I stop. So my shading looks like this. Oops. Like this. And because there's a parenthesis at a, there will be a parenthesis on my graph at a, like so. So these images mirror one another. When I think back to my set notation, what I have to ask myself is, are my values bigger or smaller than a? They're smaller. So my set notation is that the x values are less than a. And they're strictly less than a because I have that parenthesis. I can't actually equal a, so I don't put the line underneath the equals or the inequality symbol because I can't equal a. The last one it's bounded, right? It has a starting point and an ending point. I don't continue to infinity in either direction. So the interval notation for that works out just like the picture of the graph. I have a parenthesis at a, and it continues to b, and I have a bracket. So this notation mimics the set or the graph notation perfectly. I really like interval notation. The interval or the set notation for that interval then says that I start at a, and I end at b, and x is trapped between, right? It's all the values that are between. If I have a parenthesis, I will not have that equal sign. So my values go from A being the smallest to B being the biggest. So the symbols go like this. But I will not have an equal sign underneath the first symbol between A and X because I have a parenthesis here. But I will have one underneath the B symbol because on B I have a bracket. Okay, so I have a feeling you've seen most of that before, or at least portions of that, if not the whole thing. So that should be a refresher. And what we're going to do is we're going to actually use some values and then solve some inequalities and go from there. So our first ones that we're going to look at have just one of the forms, and we're simply doing the other form. So we're going to sort of fill in the missing pieces of the table, much like I did over here, but I have numerical values that I'm working with instead of just arbitrary A's and B's. So as we're taking a look at this, I kind of like to do the graph first. It doesn't matter to me what you do first, so take your pick. I'm going to draw my graph first. And I don't really care where the value is in reference to 0 or anything like that. I just want the value itself on the graph. So ours is square root of 3. That's the only value they list, so that's the only value I need to have on my graph for sure. And then I need the values bigger than 3, square root of 3, or smaller than square root of 3. It's greater. This says that it's supposed to be greater than, so I need shading to the right. Let me make my pen stroke a little bolder. Let's see if that'll help a little bit on that. Oh, that's really not what I was looking for. All right, I like that, okay. So a little bit bolder. So it's shading to the right. But then I need my interval to be equal to, which means I need a parenthesis or a bracket? I need a bracket. So my bracket itself will open towards the shading. So it'll look like that. So that's one of the two missing forms. And then the last one is interval notation, which I can read straight off my graph. There's a bracket and a square root of 3. And then it extends forever or indefinitely to the right. So it goes to infinity with the parenthesis. So those are the two missing forms. On number 2, the only value that I'm concerned with is 54. So 54 will go on my graph. Where will I shade? Left, because it's negative infinity until I get to 54. And will I have a parenthesis or a bracket? A parenthesis, just like the parenthesis in the interval notation, opening toward the shading. And then as I'm describing the relationship between x and 54, is x bigger than 54 or smaller than 54? Smaller. And will I have a line underneath it? No, because I have a parenthesis. Okay, everybody good so far? Okay, so what we're going to do now is we're going to incorporate some of the things that we were doing back in earlier sections, namely solving equations with the graphs and the interval notations. This one says we're going to solve the inequality and graph. And if it doesn't tell you how it wants the notation, it means that you can leave it in either form. You can leave it in set notation if you'd like that, fine, no problem. You can put it in interval notation. We're going to just do all of them as we work because sometimes it asks you for them and sometimes it doesn't. So I want to make sure that as you look back, you see all the pieces that are there in case you need them. So as I'm solving this, what would be my first step? Move the 1 with subtraction, right? Because it's added. So the positive 1 and the negative 1 add to 0. So I have 2x on the left and I have 5 on the right. And then I would divide by 2. So the inequality notation or the set notation is that x is less than 5 halves. It's not a very good 5. Let's try one more time. Okay, so that's my set notation. If I'm drawing my graph from that, my graph will include the number 5 halves. Will I shade to the left or to the right? Left, because it's a less than sign. Will I have a parenthesis or a bracket? A parenthesis. Okay, remember parentheses happen when I don't have the equal sign underneath. Brackets happen when I do. So this would be my graph in form. And then my inequality form would start from negative infinity because my shading goes all the way to the left with the parenthesis, always with the infinities. It will stop at 5/2 and it will have that same parenthesis that the graph does. So those are the three forms all there at the bottom. And then you just use whatever they tell you. This one said graph, so I know for sure I needed a graph. I didn't necessarily have to do the inequality, the interval notation here at the bottom based on the directions there, right? It wasn't asked for it. Set notation. Yeah, so this one's set. This one's interval. And then, of course, there's the graph sandwiched between. Okay, let's try another one. Same direction sets. We've got 3 of them. This one actually has a fraction involved. I have 5 minus 3x over 7. So what would I do first as I solve this? Multiply by 7 would be most helpful, right? Let's get rid of that denominator. So that gives me 5 minus 3x on the left, because the 7's canceled, right? Is greater than or equal to 14. What's next? Subtract my 5. Negative 3x is left on the left, because these canceled. And 14 minus 5 is 9. Then what? Divide by negative 3. So x is left on the left, and I get negative 3 on the right. What happens in between? Yeah, so anytime we multiply or divide by negative numbers, this is really important. It's only true for multiplying and dividing. And by a negative, not just by any number, but by a negative. The inequality symbol switches. So I actually have this now to be less than or equal to negative 3 instead of greater than or equal to negative 3. Help me to remind me, have I talked to you guys about why that changes before? Not yet? Okay. So let me actually show you why that changes. Let's say that I have 1 is less than 3, and we would all shake our heads and say yes. Correct? Yeah, no problem. What happens when I consider negative 1 and negative 3? Which one's bigger? It's actually the negative 1 this time that's bigger, right? Think about a number line. So when we're considering the positives versus the negatives and we alter things, right, the equivalent to what I just did here was I multiplied by a negative on both sides to make that happen. The inequality symbol switches as well. And it happens every time. All right, so going back to this particular problem now. Let's do a graph for it with my negative 3 plotted. Will I shade to the left or to the right? Left, because it's now less than. And we'll have a bracket or parenthesis. A bracket, because I have the equal sign. And then if requested, my interval notation, much like the last one, starts at negative infinity and goes to negative 3. But this time there's a bracket on the end of it. Okay, so over here, not part of our actual problem, was this a side note. And our solution's right here at the end. Any questions so far? Okay. We also have situations where we have things connecting between with the words and or. So that's my next 2 examples. We're going to solve both of them simultaneously. Like we're going to solve two of these inequalities at the same time. But then we're going to talk about what happens with the word and what happens with the word or. Okay? So first, let's simply solve what we are given. So the first thing I'll do here would be to subtract my 5. So negative x is less than negative 1. Remember, it's not addition and subtraction that change signs. It's only the multiplication by negatives or division by negatives. So this is negative x is less than negative 1. And then I will multiply or divide, if you wish, by a negative 1. And my inequality becomes x is greater, that looks funny, than a 1. Does that work? That part's fine? All good? Okay, same thing on the other one. We're going to solve that one. So we're going to add a 5. So I have 0.2x is less than 6 now. And then you can either divide by 0.2, which will be just fine, and you can grab your calculator, or you might recognize that 0.2 is the same as the fraction 1/5, so you could multiply by 5. And that will give you the number 1 as well. Either way, what is 6 divided by 0.2, or what is 6 times 5? It's 30. So on this one, I didn't have any signs changing because I didn't do anything with division or multiplication with negatives. And the reality is I have this word and between it, and that's actually a really important word. So what the word and means is that I have to satisfy both of these conditions at the same time. It needs to be both greater than 1 and less than 30. So if you take a look at the graph, you've got to satisfy both of those at the same time. So if you have to put them in order on the graph to start with, right? So the 1 comes first, the 30 comes second. If it needs to be both larger than 1 and smaller than 30, what part of this graph am I going to shade? The middle. Okay? Now, just because I have 2 of these and it says and does not always mean I do the middle. It could say greater than 1 and greater than 30. If it said greater than 1 and greater than 30, I'd only be shading the far right-hand side. Are you with me? So you have to actually pay attention to the 2 inequalities to know which one to shade. Is it off in the middle? It is off in the middle, but it's not always the middle. There are some examples in your homework where they're not the middle that's shaded. This one is. Both of my inequalities here don't have equal signs. So both of these will be parentheses, and they'll be opening inside, like toward the shading part. So my interval this time is from 1 to 30. No infinities this time. That's the word and. And means it has to satisfy both at the same time. Or is a little bit different. We're going to start out the same way. We're going to solve the 2 inequalities, but then we're going to consider what the word or actually means. So looking at this one to solve, what would I do on the first inequality first? Multiply by 2 would be good. So that leaves me, well, the 2's cancel, so it leaves me 4 minus x on the left is greater than 2 on the right. Then what? Subtract 4. I know that's what you're thinking. You just don't want to talk to me today. Subtract 4. So these add to 0. I'm left with negative x, on the left. 2 minus 4 is negative 2. And then I would divide by negatives. My signs all need to switch, so divide by negative 1, or you could say multiply by negative 1, doesn't matter. My sign in the middle will change from greater than to less than. So x is less than, negative 2 divided by negative 1 is 2. So I know my x is less than 2 from the first inequality. Second inequality, quite similar. I have a denominator, but the denominator is negative 3. On this one, the negative 3 being multiplied here will also change the sign. It's just happening at a different point in the problem, but it still changes my sign. So I have the negative 3's canceling here. I have the 2x minus 7 here, but my sign changes at this point in my problem. And I have negative 3 on the right. I'm going to shift this just to give myself a little more space. Next step. So the negative 3 gets canceled right here with the negative 3 on bottom. So it never distributes to the 2x. Yeah, because I'm just trying to cancel the denominator. Okay, what's my next step? Add 7. Okay, so I've got 2x on the left. Negative 3 plus 7 is 4. And then divide by 2, and it says x is greater than 2. There is the word or now happening between these. The last one had the word and. So instead of satisfying both of these at the same time, it has to satisfy either of them. So it's like an either or. So it has to satisfy the first one or the second one, or it could be in some overlapping piece that they overlap, which sometimes happens as well. So if you think about a number line, Well, that's not a number line. Let's try that again. The only number that's actually showing up in any of my solutions here happens to be 2. That's not usually the case. I usually would have 2 numbers, just like the last one had the 1 and the 30. So usually I'd put them both on. Here there's only 1. This one says it has to be satisfying the x is less than 2. So I'm for sure shading x is less than 2. Well, that's the left side. This inequality says I'm supposed to be shading x is greater than 2. So I'm for sure also going to be shading x is greater than 2. Because either of them have to be satisfied, not necessarily both. Obviously, if the answer said and, like if the question said and between, there's no answer that will work here, right? I can't be both less than 2 and greater than 2. It's not possible. Agreed? So if the word and had been in between here, I would have had no solution. Because the word is or, I get both sides. All right? I get both pieces in this case. And a lot of times when I have the word or show up, I have these graphs where I've got shading on the outside edges of something. There's usually a bigger gap between them. This one just has the gap that is 2, not anything like space-wise that seems there. But usually there's a space in between. My bracket or parenthesis process is actually parentheses. It opens to the left at 2 to shade the x is less than 2. It opens to the right at 2 to shade the greater than 2 part. If I were looking at interval notation for this one, it looks a little bit funny. So let's actually write out what we have here so that you're familiar with seeing it later on. The individual pieces you're familiar enough with, right? It's negative infinity to 2, it's 2 to infinity. I put parentheses on the infinities, always. My parentheses from the graph extend to my parentheses here. And what I put in between them is a U. It's the union. When you think of the word union, you should think of like a marriage ceremony, right? The union of man and wife. Union means you get everything, right? Everything. It's the family picture, I like to say, right? Like, so if 2 people come in with kids, you get all the kids, right? If 2 people come in with debt or with money, you get all the debt, you get all the money, you get everything. So in this picture, you get all of the shading as part of your answer, and it is a union that joins them. So this actually draws us into what happens with absolute values with inequalities, because we end up having things happen where we have shading on edges and where we have shading sandwiched between. So let's talk about absolute values, specifically with inequalities, and how the shading would work. Now we've talked about absolute values before. We talked about them back in chapter P. It was your favorite chapter. Y'all remember it? Okay, just checking. So back in chapter P, when we talked about absolute values, we talked about the fact that if you have an absolute value of a positive or a negative number, it's actually talking about the distance back to 0. And distances are always positive. So when we were looking at a number line, we were saying, what's the absolute value, say, of -5? What we're really asking is, what's the distance between -5 and 0? It's 5 units. Okay, do y'all remember that? We definitely talked about that. So what happens here is that it's actually saying that the absolute value, that is the distance, needs to be bigger than k. So let me redraw my picture with those symbols. We've got the number k on our number, or the number 0 on our number line. And we want our distance to be bigger than k. So it can go k further out in the right, or it can go further out k in the left. These are both distances of k away from 0, whatever k is. And when we're looking at this picture, what we're saying is we want our distance to be more than k away. That's the outside edges. So just like the last example where I had that word or showing up, and I shaded the outside edges of something, and I told you there's often a gap in between. This is the gap on this particular problem. I'm shading the outside because what I want is I want my distance, i.e. the absolute value, to be more than k away. Right? Everything out on those edges is further than k away from the origin 0. So what ends up happening in a sort of a set notation form is that we actually end up with 2 inequalities. One of them that says that x is greater than k. That's this part. This part is the x is greater than k part. Right? And or, what I was saying is or. This piece right here is that the x is less than -k part, right? The x values come before negative k. So x is less than negative k. One of the ways that I use to remember which is which is that this is a great or statement. Yes, I know it's misspelled. Humor me. It's an or statement, right? It's a greater than symbol, and I have an or statement that comes from it. And I end up getting the edges anytime that happens. The other one says that my distance is supposed to be less than k. So from that same number line perspective that we had before, I have my 0. I have a distance of k to the left and k to the right. Right? They're both distances of k away. But I want my distance to be less than k away. So it's the sandwiched in between part. So my shading actually ends up in here instead. I'm sandwiched in between. You might notice I'm not putting parentheses or brackets. They'd work just like before. The first one didn't have the equal sign, so it should have had parentheses, right? This one has a less than, or has an equal sign, so it'll have brackets. Okay, but they're interchangeable. They work just like what we were talking about before. So this one says that I'm supposed to be sandwiched in between because my distance, okay, try to remind yourself that anytime you see absolute value, you're really talking about distance. My distance is less than k away. I'm short. I'm sandwiched in between two particular values. So I end up with an inequality that actually is looking like this. My inequality sandwiches between negative k and k. I have the piece that's happening between. And my inequalities are still less than or equal to, just like they were in the original absolute value notation. I call it a triple inequality, and they happen anytime you have a less than symbol. And again, this has a very nice less than. It's an and statement. And means I'm sandwiched in between. Okay? Sandwiched in between. I have to satisfy both at the same time. So we're going to do 2 examples, obviously one of each variety, so you can see how they work out in a particular inequality. I encourage you to first identify what the symbol is telling you to do. Is it and or is it or? Okay? This one is a great or symbol. So anytime I have or, what I should be remembering is that I have the edges of my graph. Or gives me edges. And it gives me 2 separate inequalities. One inequality looks just like this one without the absolute values in there. So it's 3 minus 2x, greater than or equal to 5. Identical, swipe the absolute values away. That's one of them. That's the right-hand side. Okay? Bigger than 5. In this case, 5. The other side means that I have to be less than the negative part of that. So I have the 3 minus 2x. And another thought you can be processing, if it helps you to remember it this way, is that I switch both the sign and this sign. That is the inequality sign and the positive negative sign. They both switch at the same time. Because what I need over here is I need this to be less than 5. That's negative. So 5 and bigger, negative 5 and smaller. Those are the 2 different inequalities. In a very real sense, this one corresponds to this piece, and this one corresponds to this piece. And I have the word or between them. Okay? So we're going to solve those 2 inequalities. And of course, they'll solve very similarly because I have the same expression on the left-hand side. So the first thing I'll do is I'll subtract my 3. So I have negative 2x is less than or equal to negative 8. I'll divide by negative 2. What do I need to remember when I divide by negative 2? The inequality will switch, so now it's greater than or equal to. Negative 8 divided by negative 2 is 4. Okay, so that's one piece solved directly. The other one, same steps. I subtract my 3, negative 2x. But notice I don't get anything to do with 8 here because it's positive 5 minus 3. I actually get a 2 here. Dividing by negative 2, just like before, I have to switch the direction of my inequality. And 2 divided by negative 2 is negative 1. So from a number line, I need to put them on there in order. This is the negative 1. Comes first. The 4 is bigger, so it comes second. And notice, because of my dividing by negatives, what was on the edges over here actually switches, but it's still on the edges, right? This one says greater than 4, so 4 got put on the right-hand side, but I'm still shading bigger than 4. I'm still shading to the right side of 4. And it's still brackets because I have the less than or equal to's and the greater than or equal to symbols. The other one, the negative 1, says I'm supposed to be less than negative 1, which will be to the left of negative 1. So we'll shade to the left. And I will have a bracket opening to the left. So this is like the one where I had everything shaded except the number 2, but I now actually have a legit gap between them, right? So as I'm writing my interval notation, I still write it from the left to the right. I start with negative infinity, but now I will stop with negative 1, and there's a bracket there. It's always a union when I've shaded those outer edges. An or statement is a union. I pick up at the number 4 with a bracket, and I shade over to the right forever, so I continue on to infinity. Any questions on that one? So that looks just like what we did before. The next one's going to look different because it isn't going to actually have the same form we've seen on any of them so far. It's going to end up having this notation where there's a triple inequality. Okay, so it's going to look a little bit different. It is a triple inequality because this is a and statement, because it's less than and. And so what that actually means is that I need to be within 2 of my number, right? So I need to go from the left 2 to the right 2. This is the shading that I'm doing. That's why I have a triple inequality happening, because I need my distance to be less than 2. So it needs to be sandwiched between negative 2 and positive 2. That's my setup. So my inequality setup looks just like that shading. Negative 2 to 2, and it's sandwiched in between 6 minus 4x. That is not quite enough space. Better. How do I know that I use these symbols? Well, I use these symbols because I have to start from the left and move to the right. It's like I'm reading. The negative 2 is smaller than positive 2, so my symbols always open from the negative side to the positive side, from the smaller side to the bigger side. So that's why I'm using less than symbols here, and that will always happen when I set these up. Now, when I solve this, I actually solve it in all 3 pieces at the same time. So I need to get x alone in the middle. So the first thing I need to do is to subtract a 6, but I have 3 sides to my inequality, so I'll have 3 places I subtract the 6. Negative 2 minus 6 is negative 8. In the middle, these add to 0. So I have less than, and I have the negative 4x left. And then 2 minus 6 is negative 4. Then we're going to divide by negative 4, all 3 places. Negative 8 divided by negative 4 is 2. In the middle, they cancel. I have x. On the right, negative 4 divided by negative 4 is 1. But we divided by a negative, which means what happens to my symbols? They flip. So instead of less than symbols, I now have greater than symbols. But that should make sense, Because this is now saying, if you ignore the x in the middle, 2 is greater than 1, and that's true, right? If your symbols had been left the same, that would be a false statement. 2 is not less than 1. So the symbols have to change in order for the statement to make sense. In an interval, I now have 1 and then 2, because 1 is smaller than 2. I'm shading in between. Neither one have the equal signs. They both say strictly greater than. So my shading will or my intervals will open with parentheses to the inside. And then if I'm looking for interval notation, it starts at 1 with a parenthesis and it ends with 2 at a parenthesis. Any questions on that? I always feel like, especially with absolute value stuff, that everybody seems to get it in class, and then homeworks and quizzes and exams all really seem to struggle on absolute values. So make sure as you're processing along in your homework, you're referring back to your notes and making sure you've got everything in sort of the right order, okay? All right, so this one will be due on Thursday.